Now on ECOC TV, we are very happy to have been joined by the CEO of one of our official sponsors, Hyperlight, Mian Zhang. Thanks very much for taking the time to speak to us, Mr. Zhang. It's your first time speaking at ECOC Market Focus. Could you tell us who Hyperlight is and what is this technology that you're introducing to the market?
Yeah, so Hyperlight, we're a startup funding in 2018, and then our company spun out of Harvard University, and it's based in Cambridge, Massachusetts, in the United States. So we design and produce photonic integrated circuits based on thin film lithium niobate. The key advantage of our technology is we offer ultra high performances, but at the same time being cost effective. So in particular, the optic engine we built is low optical loss, high electro-optic bandwidth, and low driving voltage. So these are all challenging to realize in existing photonic integrated circuits platforms. So these factors, what we believe is key to meet the demanding requirement for next generation photonic applications, for example, for low power, high bandwidth solutions in data centers, telecommunications, microwave photonics, and also emerging applications, for example, in sensing and quantum photonics. So Hyperlight's photonic chip can really enable our customers with unprecedented system level performance gains and capabilities.
Exciting stuff. At Market Focus so far, it's been mentioned by various speakers that demand for higher bandwidth and power efficient technology in optical communications continues to increase. Based on what you've just told us, thin film lithium niobate seems to be a strong contender to existing photonic solutions. Can you tell us a bit more about this and why it's relevant?
Yes, indeed. So lithium niobate is actually a very well-known material. So in its bulk form, it's very versatile electro-optic material that actually has been used in industry for decades. It is often in the form of packaged gold boxes. It has a lot of applications, for example, in high-speed optical communications and also in analog photonic links. So this is because the electro-optic property of lithium niobate is actually quite ideal, and the material is very, very stable. So this has been proven for the last 50 years through industrial scale development. But the issue is, despite that it has great performances, what it really has been lacking for lithium niobate to meet today's demand is its large form factor and really high cost. So at Hyperlight, what we do is we apply silicon photonic fabrication technologies, but using that to process thin film lithium niobate. So basically, we make waveguides, splitters, modulators, just like we do in silicon. But unlike silicon, now we're using it with a material that has intrinsic strong electro-optical properties. So now, when you combine all of these factors together, what you get from the thin film lithium niobate electro-optic modulators is that even today, what we produce already features sub-volt driving voltages, basically at the CMOS level, bandwidth greater than 100 gigahertz, and then at the same time, very low insertion loss. So these numbers are very much demanded and wanted for other photonic platforms, but they're really difficult to achieve even after decades of R&D. So at Hyperlight, we're able to achieve this within only a few years of inception of this technology. So probably not very surprising that we also have evidences internally that these performances can be pushed even further for future applications. So for example, very recently, we partnered with Nokia Bell Labs, and we're able to demonstrate record level performances, for example, for IMDD. So that's a single modulator, direct modulating, direct detection of a single channel up to 700 gigabits per second. And we also did coherent modulations up to 1.55 terabits per second and running at 200 gigavolts. So these are really, really high speed demonstrations that was very difficult to do previously. And more recently, we also have started several efforts with key equipment providers, component vendors, and partners to put this device advantage really to a system level. So we're really excited about that, and then what this can do for future high-speed and power-efficient networks.
It sounds like there's much more to come from Hyperlight. You mentioned there that you've been working with network and equipment providers, component vendors, and other key partners. What's the future looking like for Hyperlight, and how can interested customers reach out to you?
Yeah, that's a great question. So for Hyperlight, our goal is really to empower our customers with ultra-high performance and cost-effective photonic integrated circuit solutions to enable them to have a system-level performance gain for their applications. So we're really excited to work with our customers to solve their next big challenge. So you could visit us at our website, hyperlightcorp.com, or you can email us at info@hyperlightcorp.com.
Thank you very much, Mian. Lots of different ways for people to get in contact with you. And of course, if people do want to find out more, Mian will be giving a market focus presentation at 12:40 on Wednesday. Mr. Zhang, thank you very much for taking the time to talk to ECOC TV. And we very much look forward to hearing more about Hyperlight in the future.
Thank you, James. It's a pleasure.